Hey everyone, it's Dr. Calkins, week 5, chapter 5, homework questions that were submitted, or at least that have been traditional questions from students in the past. So we'll start with number 3. Number 3 says, what is a covalent bond? Well, remember, metals and nonmetals have ionic bonds, and that's when a metal gives and a nonmetal takes electrons. But here we have sharing of electrons between two atoms. That's the big idea of this chapter when we do Lewis dot structures. Number 4 says, how many covalent bonds can an element in group 5 share with other atoms? Well, if you're in 5, you're like nitrogen. You have 5, so you can share once, twice, or 3 times. So 3 is the magic number for 5 because the magic number is 8 overall. The octet rule applies. Number 6 says, what is the Lewis dot structure for selenium? 1 on each side, so that's weird. 1 on each side, so that's weird. So then we're down to this one. Here's 6, here's 8. So this one would be a selenium -2, but not the answer. So there we have A. So number 8. 8 says, how many valence electrons in boron trichloride? So in order to figure that one out, we have to go to the periodic table. Boron has Roman numeral 3, so it's in family 13. Roman numeral 3, and then we have chlorines, and this Roman numeral 7, group 17. So we just add them up. When we add them up, we get a 3 valence electrons plus 3 sevenths, so that's 21 plus 3, that's 24. Number 10 says most polar. To know most polar, we have to use electronegativity. So the first one was carbon to carbon. That's going to be 2.5, 2.5. So 2.5, 2.5, that would be least polar. So that's 0 difference. Carbon to fluorine would be 2.5, 4.0. 2.5, 4.0, that's 1.5, that's very polar, so far the winner. Carbon to hydrogen, 2.5, now subtract 2.1. So in that case, 0.4. So that's non-polar based on our definition. I need to be 0.5 or larger. And then carbon to chlorine, we have 2.5 and now 3.0. So we want the biggest difference. This is absolute value, so it doesn't matter who you're subtracting first or second. About 1.5 is going to be the winner because it is the biggest. To be ionic, you have to have a metal, and only sodium is a metal out of that entire list, so that one's a little bit easier. Ionic is going to be typically 2.0 and larger in electronegativity difference if you were to look. Sodium being so low in electronegativity, 0.9, and then fluorine being 4.0, that 3.1 definitely much, much larger than 2.0 required to typically be ionic and separate. Number 13 says, what is the chemical name? Well, we don't use prefixes unless we have nonmetals, and potassium is a metal. K is a plus and oxygen is a -2, so that's why we have the 2 in front of K and the 1 behind oxygen. So we cross these charges, and that's why we get what we get. We don't use oxygen. The more electronegative atom ends in IDE because it's binary. This is binary ionic, so potassium oxide. IDE is always going to be binary. Very few exceptions to that in Intro Chem. 15 says rhenium 7, so that gives you a +7 charge. Oxide is a -2. So you're going to cross a 2, cross a 7, so look for 2s and 7s. Bingo. 18 says potassium bicarbonate. Potassium is K+, bicarbonate is HCO3 -1. Those ion lists in the back of your table, lab book, in a table form supplemental 6, I believe. So these are a perfect match, so squish them together. K+, hydrogen carbonate is the same thing as bicarbonate. So this would have crossed a 2, that's wrong. This would have crossed a 2, that's wrong. This would have crossed a 3, that's wrong. 19, the most important table for really the rest of the semester. It tells you who likes electrons. It's called electronegativity. So very important to know. That tells us who is sharing well and who is not. It's basically our bully system. Number 21 says, who has a covalent bond? Remember, covalent means sharing. And if you're sharing, you're typically nonmetals. So get rid of the ones that have metals. Potassium, sodium's a metal, lithium's a metal. There's only one left, and that's the answer. So ionic bonds would be metals. Covalent bonds would be nonmetals. So get rid of the metals. Number 22 says not binary, so basically not IDE ending. IDE is typically always binary. Here we have IT, so sodium hypochlorite would be NaClO, so notice there's 3, that's ternary. Sodium chloride is NaCl, sodium hydride is NaH, and sodium sulfide is Na2S. That's only a 2 there because of sulfur's charge. But only 2 elements, only 2 elements, only 2 elements, but 3 elements would be non-binary, that would be ternary. Very similar but different with 24. It says who is not binary, so that's 2. Ionic is metal and non-metal. So find a metal. Potassium's a metal. Everybody else, sulfur hexafluoride, SF6. Phosphorus tetrachloride, PCl3. Those are 2 nonmetals sharing. 2 nonmetals sharing a lot. And then water is H2O, 2 nonmetals sharing a lot. So those are binary. They're just not ionic because they lack a metal. 25 says, which one is ionic binary again? So binary again means 2, ionic means metal, non-metal. Just more choices here. Here we have 4, definitely more than 2, so get rid of that one. These were binary compounds here. They were both molecular, covalent, so not binary ionic. Here we have 2, here we have 2, here we have 2. Each one has a metal. So that's ionic and binary, so that's the answer. As we practice the rest of them though, here we have 2 and 2 and 2. So these are all binary, they're just non-metal, 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 non-metal. Those would be binary covalent, not binary ionic. And then here we have a problem because we have 3, that's ternary. This one's ternary. Cobalt chloride is binary ionic, so only one of those 3 were actually binary, but they were all ionic. Be careful, watch for the metal, and you should be okay there. As you get to questions like number 30, who has the same number of valence electrons as sulfur? This is what Dmitry Mendeleev did and didn't know it at the time, and that's family. So look up and down your family for sulfur, because all of those have Roman numeral 6. So if you look on the periodic table, who's going to be the same as sulfur? Could be oxygen, could be sulfur, could be selenium, could be tellurium, polonium even would count, but it's radioactive, nobody cares. So in the case here, who do we have? We have oxygen. Boron is in the family 13, arsenic in 15, nitrogen also in 15. So they would have the same, but not the same as sulfur. Number 33. What would be the expected formula between silicon and fluorine? Well, draw silicon. Roman numeral 4 family, so it's going to have 4. That tells us it's going to want to share with fluorine 4 times. So find that SiF4. So it has 4, it needs 8. It's going to have to share with 4 fluorines to get 8. Very similar down here with C2H6O, make it symmetrical. Go to the Roman numerals, carbon has 4 just like silicon above, oxygen has 6. Carbon has 4, connect those dots. In our next chapter, at least in 2 chapters, we'll see a better reason for this. This is the ether molecule. So you're going to have those 6 hydrogens attached over here. Each one has 1, you connect the dots. So how many single bonds do we have? We have 4 around each carbon, just like we'd expect, and 4 and 4 make 8. Acetylene, this one was in the notes. Acetylene, carbon has 4, carbon has 4. Hydrogen never in the middle because it can only share once. Connect, 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 connect. So this was one of our examples in our notes for a triple bond, but it also has single bonds. So triple bond here, single bonds there, A and C. Methane is CH4, carbon has 4, hydrogen 1, so connect those, and you'll get 4 of those bonds. So it likes 4 bonds, 0 lone pairs. We would have seen that in lecture as well. That's the preference for carbon and carbon family atoms. If you move over, it still needs to be 4. This is 5. This is only 2. This is only 3. So when that happens, just be aware that the magic number is 4 pairs because you can only have 8 electrons. So even these up here would be crazy because that would be much more than the number of pairs you could have to make 8 total electrons. The reason that phosphine though does this is because phosphine has 5, it's going to connect to 3 hydrogens. And that's going to give you 3 bonds and then 1 lone pair. The number of valence electrons in carbonate. Carbonate is CO3 negative 2. So carbon is 4 electrons based on its Roman numeral. Oxygen would be 3 times 6 electrons. And then the negative 2 charge means 2 more electrons. All of those added together would be 18 plus 2 plus 4, that's 24 electrons. So count up the Roman numerals. We'll be doing that in lab very soon. (44). Which one has a triple bond? Nitrogen is 5 and 5. So connect, 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 and bingo. For practice though, water has 6 on oxygen, 1 on hydrogen. It's got 2 single bonds. Oxygen again has 6, but with another oxygen that has 6, it has a double bond. Carbon dioxide has 4. Oxygen has 6. And you get 2 doubles. And that answers the next question. Carbon monoxide's a tricky one. It's got 10 electrons. It's going to have a triple bond. You'll see that one in lab. Oxygen, nitrogen, we already did in the previous problem. Number 48, remember all transition metal cations. The list is in supplemental 6, front page, right side column. So you could have stole those answers from here. This plus 2 is tricky because all of these are plus 2. This is Hg2 plus 2. This is cobalt plus 2. This is stannous, so 10 plus 2. And then iron plus 2. So it says which one does not have a plus 2 charge? Well, it looks like they all do, because they do. But if you remember that this is 2 over 2, that's really plus 1 each. And that's the answer, mercury rust. That's a unique one. It's also the answer to number 50, we'll see that in a second. Which one is the highest ick? Iron likes a 3. Stannic, based on its family, likes a 4. Cobaltic likes a 3. And mercury likes a 2. So who is the highest? That's the highest family. This would be in group 4, group 14, in a non-Roman numeral sense, so definitely the highest charge possible. Number 50 says which one has the least positive charge? Well, again, ferrous is a plus 2, mercurous is a Hg2 plus 2, stannous is a plus 2, and cobaltus is a plus 2. So again, least, they look the same, but the least is 2 over 2. That's really a plus 1 each. So for the same reason, this is the answer to 50. 52 says which one has an oxyanion? Those tend to be in ATE or ITE ending. ATE is T43 based, ITE loses an oxygen. So which one is ATE, IDE, IDE, IUM? So definitely the only one is perchlorate, that's a ClO4, negative 1. Chloride is a Cl negative 1, ammonium is an NH4 positive 1, and bromide is a Br negative 1. Same family, same charge for those two. Notice this is the only one that has oxygen. Those are oxyanions, those are the ternary polyatomic ions. Number 53 says which one is not an ick ending acid? Well, it comes from 2 things. You could say my ride has hydraulics, so IDE makes a hydro-ick. And also, I ate something icky, so ATEs will also make ick acids. So this is hydrogen cyanide, so that's IDE. My ride has hydraulics, says that it's going to be an ick acid. It's also going to be a hydroic acid. Whoops, this one says not, so we better leave that one alone. This one is IDE, so this is hydrogen fluoride. So it also would be an ick ending acid. So, just like A, both of these would be hydroic acids. So both of these would be ick ending, they went not. I was just getting a little overeager. H2SO3, that comes from sulfite. Ites are going to give you OS acid, so this is sulfurous acid in the answer. It would be H2SO4, that's the sulfate ion, and 8 gives you ick acid. So stay away from A, those were hydroic, and this was a ick acid. OS acid, there it is. Number 55 says which one has the most atoms? Hydrogen phosphate is HPO4 -2. Ammonium is NH4 +1. Carbonate is CO3 -2. Acetate is CH3COO -1. Most atoms would be 1 + 1 + 4, that's going to give you 6. 1 + 4 is going to give you 5. We're just adding up these subscripts. 1 + 3 gives you 4. 1 + 3 + 1 + 1 + 1, that's going to give you 7, and the winner. Most atoms, biggest formula. Number 57 says, which of the following oxygen atoms equal to a number other than 3? Dihydrogen phosphate is H2PO4 -1. Carbonate is CO3 -2. Chlorate ClO3 -1. Nitrate NO3 -1. So they want somebody that doesn't have 3 oxygens. Once you look those up, you're going to see that phosphates are in the 4 box. They have 4 oxygens, not 3. 62. Which of the following anions has its number of oxygens equal to 2 and a -1 charge? So bicarbonate is HCO3 -1, so it has the right charge, wrong number of oxygens. Nitrate is NO3 -1, right charge, wrong number of oxygens. Chloride ClO2 -1, number of oxygens is 2, charge is -1, so bingo. And then permanganate MnO4 -1, so right charge, wrong number of oxygens again. So gents, if you know what your ions look like, these aren't so bad. So if you have your table close, these will go quick. If you're by yourself, you end in IDE, even hydrogen. So find IDE, IDE. Just remember hydroxide is oxygen and hydrogen, so not that one. It'll be this one. 67. Which one does not have a parenthesis? So sodium is Na+, dichromate is Cr2O7 -2, so you'll get Na2Cr2O7. So no parentheses already. For practice, let's do the other ones. This is ammonium and carbonate. So across the 2 you get ammonium twice, carbonate once. Magnesium is A+2, dihydrogen phosphate is H2PO4 -1, so Mg once, H2PO4 twice, parentheses. Aluminum is a +3, bicarbonate is a HCO3 -1, so we get aluminum once, but hydrogen carbonate or bicarbonate 3 times, that's parentheses, and not the answer. 68 says, which one has 3.5? We said 2 or larger is ionic, and 3.5 is definitely larger. You're going to need somebody from the very far left, which is the metals, and the very far right, which is the non-metals, for that kind of subtraction to happen. 69 says, if you're 1.0, we would call you polar, covalent. You're sharing, just not sharing very well. That's why that 1.0 difference is found. So it's just definition based. 0.5 or larger is the difference between polar and non-polar. Above 2 is ionic. Number 70 says resonance of nitrate, nitrates. Oftentimes you can just look at the number of oxygens, that's 3, and then circle it. Even if you were to say nitrite, 2 would be the answer. The reason for that is because the double bond could be in any of those locations. I'll just give you the answer real quick to save some time. So here's the nitrate ion. And notice the double bond could have been here, 1, could have been here, 2, could have been there, 3, that's resonance. If it were nitrite, you only have 2 oxygens, have a double bond 2, and that would only be 2. So oftentimes you can cheat off of this subscript to know the number of resonance. Just know that if you have 4, you can't have 4. If you had 4 for, say, a phosphate or a sulfate, you're going to have 4 single bonds. There would be no resonance there. Home stretch, true and false, a little bit of matching, and we're done. Big homework though, biggest one so far this year. If you're by yourself, you end in IDE, so that'd be phosphate. Phosphate is PO4 -3, that's the T43 ion. So phosphate would be that, phosphide would be that. So there we go with a false. Electrons in the carbon-chlorine bond. Carbon is 2.5, chlorine is 3.0. We see that from electronegativity. So 2.5, 3.0. If they were to be shared equally and exactly, that would be 2.5 and 2.5, or 3.0 and 3.0, so we found another false. They're only shared equally if they have the same electronegativity, and specifically if they're the same atom. Covalent bonds, if you break a bond, it releases energy. Well, we said if you're forming a bond, you're being noble gas-like, and that's sharing. Everybody's going to get their 8, everybody's going to be happy. That happiness is released when the bonds are formed, not when the bonds are broken. When you break bonds, just like breaking a window, it requires energy. So it pulls energy in, it doesn't release it. So that's another false. Number 80 says sulfur tetrafluoride is expected. Well, sulfur has 6. So we'd only expect sulfur to share twice from those unpaired electrons, not 4 times. So yet again, another false. Hydrogen cyanide, IDE. My ride has hydroic acid, so perfect. That one's true. Ides do make hydroic acids, even for cyanide, which is actually ternary, not binary. Perchlorate, which is ClO4 -1, phosphate, which is PO4 -3, and sulfate, which is SO4 -2, all have the same hydrogen atoms, which is 0. So that one's true, but kind of tricky. 0 is a number, and it's the same for all 3. This is binary, and binary ends in IDE, just like with number 71. This is calcium phosphide. Calcium phosphate would be this one. Across the 3, across the 2, much bigger, much scarier. So false there, because ATE would have been this one, but this one is the IDE binary ionic. And a little bit of practice and matching and we're done. Carbon dioxide, saw that one on the earlier, so I'm not going to redraw it again, but 4 connected to 6 connected to 6 gives you 2 double bonds, so only double bonds, A. Ethene is C2H4. Again, this was CO2. C2H4, you're going to have a double and some singles. Ammonia, we would have done this one in lecture. 3 single bonds, 1 lone pair. Oxygen is O2, just like ammonia was at NH3. So double bond only. And then hydrogen cyanide, H, carbon with 4, nitrogen with 6. See this one in the lab book as well, as a single and a triple. So only one out of place is O2, that's a repeat of A. The rest were in perfect order. So big homework, but lots of practice we did together. So see you next time.